And you're back here on Open. Daren Jaime with you. Hope your day is a bright one. We're discussing global warming and other factors affecting our environment. Scientists and explorers have been fascinated with Easter Island, which, in case you didn't know, is an island with large stone statues located near Chile. Scientists have recognized Easter Island as a location with the most extreme example of deforestation in the Pacific, as well as the world. Let's take a look.
His team was looking for large coral to provide cores, which will give us information on past weather patterns. To get this information, divers head out to Cook's Point, about a mile from the shore. There they found one of the largest briny sapata corals in the world at a depth of 65 feet. Coral cores act as a tape recorder of weather over time. As coral grows, it produces growth rings similar to those of trees. Each foot of coral growth represents about 100 years. We were able to obtain coral cores up to 6 feet long, representing 500 years. Much information is contained within these coral rings. When analyzed, it should give us a history of temperature, rainfall records, and data such as evidence of severe El Niño episodes in past centuries.
What we will do then is take these coral cores, like the one I have here, bring it to Stanford University, and we will analyze the oxygen isotopes and trace elements to help reconstruct the temperature and perhaps the precipitation signature that may be here at Easter Island.
Cores taken from coral are a time capsule of weather changes in past centuries. They also provide other valuable information. They allow us to measure the increase of carbon dioxide released into the atmosphere. Many scientists believe the increased use of fossil fuel is causing an increase in global warming, better known as the hothouse effect. This is the research area of Drs. Warren Beck and George Burr.
We're here to study the effect that man is having on the atmosphere and the known increase in CO2. And we're interested in how the ocean absorbs that CO2 as time goes on and at what rate it absorbs it. And Easter Island is of particular importance because of its proximity to the equatorial waveguide, where you have a lot of upwelling from the ocean. And our climate is strongly affected by the exchange between the ocean and the atmosphere. Corals act as a tape recorder. As they grow, they leave layers, and so we can identify individual years or even seasons. And they absorb the C14 that's in the surface ocean at that time. This, in turn, has exchanged with the atmosphere. So we'll take the corals, we'll slice them, and we'll identify individual years, and we'll make measurements to see how this C14 is varied through time.
El Niño has a strong moderating influence on how fast CO2 enters or leaves the ocean. When you have an El Niño, it actually enters the ocean faster than during a non-El Niño period, and vice versa. So we can see El Niños in the coral, because when you have an El Niño, the radiocarbon concentration will go up, and when you have a La Niña period, which is the opposite polarity, the radiocarbon concentration will go down.
And joining me now to discuss the exclusive images we saw are Dorothy Peteet, a research scientist from Columbia University, and Bob Hemm, an avid traveler, documentarian, and a member of the Explorers Club. And thank you and welcome both to the show.
Thank you.
Thank you.
And we have to put that out there, that we did hear Bob's voice out there. And
That's
that was,
right.
and you've been out to Easter Island.
Yeah, I've been there 8 times all told from 1996 until just about 2 years ago. And we did this particular expedition in 1997. So as you can see, global warming isn't something that's that new. I mean, there's scientists have been looking at this for a long time, but the proof keeps building through using many, many models. And just some of the ones you've seen here, like the coral, is more of a top kind of a 10-year, or excuse me, 500-year. Every coral foot is about 100 years. So we got 5-foot corals. We go back 500 years. But we're talking about going back in this case, maybe millions of years, and what's going to take place in the next few hundred years, or maybe few decades. This is what's happening.
Give us a little bit of a definition for somebody who might be a novice to what global warming is about, because we hear a lot about it in the news, we talk about it here in the media, but then yet and still there's some people who just really don't have that definition of what global warming is all about. Let us know.
Okay. I can give you a little bit about it. I work at NASA Goddard Institute too, where the atmospheric scientists are studying and modeling global warming. And basically you have a thin skin of an atmosphere around the Earth, and what's happening is that with pollution we're putting up various gases which are called greenhouse gases, and there are things like carbon dioxide that we that comes out of our cars and buildings, and the more those gases get in the atmosphere, the more they trap heat. And so people call it the greenhouse gas, because it's sort of like a greenhouse trapping in the heat in the Earth's atmosphere, and then the Earth warms up. The oceans and the land both warm up.
Can people say, from what we are seeing now with the, with the warm climates, the warm temperatures, that this is an effect of global warming?
There's no doubt about it. I think it's been charted. For instance, 2005 was the absolute warmest ever recorded in history globally, not just the United States, but worldwide. And I think the last 14 hottest have been something over the last 20 years, so it's building and building. I mean, we can't go by what's just happened these last few months. It's been extremely warm here, and so in New York we say, wow, global warming. It does sort of go up and down, but its trend is constantly upward. And there's no doubt about that. It's been charted that well.
Mm-hmm. You talked about pollution, how pollution affects
Right.
global warming. Is there a way to remedy the situation? I mean, of course we could talk about, trying not to be so polluting of the atmosphere, but once the damage is done, I guess somebody says, is the damage done?
Well, it's in the atmosphere for a long time, carbon dioxide is. The ocean takes it up, and the plants sequester carbon over a long time. But we're putting so much in. We're off the charts. If you look back in time, we can look at corals, we can look at tree rings, we can look at sediment cores in the ocean, and on land, in lakes, that's what I look at, and in wetlands. And we've never in our history, and the ice cores tell us from the gases trapped in the bubbles, have we ever seen CO2 this high? We're just off the charts. Mm-hmm. So we know that in the last 2 million years we've never gone this high, and although we've had warming periods, they were not man-made, and the CO2 levels were never this high. But we can do some things about it. We can do a lot about it in terms of saving energy.
Bob, after you traveled to Easter Island and you saw what was going on, talk to me about what your thoughts were.
Well, first of all, when you look back at Easter Island, and Dorothy's a good example of this. She's a botanist, a paleontologist. She studies long-term. And one of the drillings we did there was something like 80,000 years of pollen and seeds going into one of the volcanoes, which was a watery mass at that point. But, Easter Island was filled with trees, and we believe there was one last tree somewhere around 200 years ago. And somebody said, well, it's the last tree, and if I don't cut it down, somebody else will. So it's that kind of an attitude of saying, well, I'm not going to try to save on gasoline or polluting because, it's just me.
Right.
But all the me's make up the difference. And this is one of our problems right now. How can you justify buying cars and trucks that you don't really need? We use more energy than anybody, and we throw more gas out than anybody. We are one of the better ones on EPA standards compared to, say, China or other countries where they pollute more by far than we do. But it's the totality of this, as Dorothy said. When you put that much in, when you see the coal-fired plants in China and in this country, there's no standards in many cases. Mm-hmm. All you see is smoke belching into the atmosphere, which is very, very thin. It's very thin. We think of the atmosphere, look up, you see the sky, and you think it's forever. A lacquer around a big globe would be the thickness of this atmosphere. That's how thin it really is. And there's more of us. The population's increased, almost tripled, almost in my lifetime. You're now talking about 6.4 billion people, and we're looking at 9.4 billion people in 2050. excuse me, what does it be, 2010 or 2020? But what's the difference? 20 years, you're going to get another 3 million people. They all use energy. They all burn trees down to plant rice fields and other farming. All of this contributes. The trees don't soak it in.
Take me through a little bit of a historical timeline of how things, about the declination here, because I mean, it's important for people to understand how things have, progressed down through the years and to bring us to this place. Talk about where we were and give us a little bit about where we are.
Well, if you go back in time to when Europeans came to North America, that's some of the cores that I've looked at here. In Manhattan, we can clearly see the arrival of the Europeans because they cut down all the trees. So we see ragweed, the thing that a lot of people are allergic to and don't like. We see that jump up in our pollen records. We can track. In the 20th century, we've reforested a lot of the New York area. So we see that as a positive sign. But this whole industrial revolution really started in the 1800s. We started to see a big increase in CO2 and methane, some of the other greenhouse gases. And right now, as we said, we're off the charts.
Give me a little bit about the Earth's history.
Earth history? Well, let's put it this way. I mean, if you go back in time, you can say one of the great weather predictors would be a strike by an asteroid or a meteor. So like 200 million years ago, I think a big meteor hit the Gulf of Mexico, and scientists now say this is probably the cause of the destruction of all life on the planet, with the exceptions of those able to survive. Certainly the dinosaurs all went. And this is worldwide, and they know the timeline on that. Then you have something like a Krakatoa, which is an eruption by a volcano, which brought on an ice age. But those are exceptions. What we're doing is constant. You're going to have nature's exceptions, and you're going to have ups and downs because of the jet streams and the reformation and so forth. You have El Nino switches, but you could see ice caps melting right now. And this is one of the questions asked. All you have to do is look at Greenland now, look at 20 years ago, 30, 40 years ago, and look at now. Over 40 years, we've seen large parts of Antarctica disappear, some the size of, say, Rhode Island, disappear into the water. That raises the water level. In the Bronx, in another 40 or 50 years, you may have a 20-foot rise. What is the Bronx going to look like with a 20-foot rise of water? And Manhattan, and many other places around the world. And that's where the world lives, around the perimeters of water.
And when you talk about a 20-foot rise, I mean, when you talk about a 20-foot rise, immediately one looks back and says, New Orleans, Katrina,
Right.
And then we look here and we say, which has been said, the possibility that, New York could be another victim, almost like Katrina. Agreed.
A good point, but New Orleans, parts of New Orleans were already 14 feet underwater, and they built up levees and so on to contain it until they got hit by these big hurricanes. But we're talking about Manhattan, for instance, or the Bronx, where you may have a 10 or 12-foot difference between the river, in this case that we're surrounded by, and land. You put another 10 feet on top of that, and that goes worldwide. That's because all that ice is a tremendous amount of water.
All right, well, we do have to take a quick break. I want you to stay with us. We want to tell you our guests are going to stay with us. But when we return, we're going to talk more with them, and we'll also find out about how global warming is affecting Bronxites. So stay tuned for more Open right after these messages. And we're back here with our guest, Dorothy Peteet, a research scientist from Columbia University, and Bob Hemm of the Explorers Club. And of course, we're just glad to have you with us. As you heard Baratti's story, talking a little bit about the climate changes and things that are going on here in the Bronx community. A lot of people have an open eye. And speaking of open, we opened up our emails, and we tell you that you can call in at 718-960-7261, or you can send us an email to open@bronxnet.org, and we'll put your emails out there. We want to tell you that we do have some emails with some questions coming from some of our Bronx students at the Bronx High School of Science. And Kevin Liu asked this question: what proof is there that global warming and its consequences are just not part of a cycle that happens every so often?
Well, as I mentioned earlier, we have records from ice cores as well as terrestrial records, and they show us the level of CO2 in the past, over 2 million years, and we've never had this high of a record. We have had warmings in the United States, and droughts in particular, that are more severe than what we've seen in the past couple of centuries here, but they were regional. What's different about this is that we know the forcing CO2 And we know that it's global, not just in one region of the globe.
Now, Jenna Rosenberg, who's also a Bronx High School student, has asked this question. When is the melting of polar caps predicted to happen, and what makes you believe that there's a global warming occurring? We've talked about that. And isn't global warming part of a cycle? We talked about that as well. But when is the melting of polar caps predicted to happen?
Well, as I understand it, it's being predicted to happen much closer to our timeline than we initially thought, which means there's a consequence when ice starts to melt in large amounts, which means you expose the ocean to start with, which loves to suck up the heat. When the ocean gets warmer, the temperature drops ever so slightly, but year by year, ever so slightly, but the buildup is considerable. So that then the ice melts even more. It's like putting an ice cube in your drink, whatever you may be drinking. If you leave it long enough, no matter how cold the water is, the ice will melt. So what you're seeing is the consequences of what we know to be the CO2 buildup. I mean, there's no question about that. As the sun comes down, hits the earth, much of that radiation from the sun used to bounce off and go through the atmosphere. It's being trapped. So it sort of hits that part and comes back down. It's sort of settled, just like a greenhouse. It's really like a greenhouse. That's why you can grow stuff in winter in a greenhouse, just by the sun's radiation. It's blocked from leaving. So we see this happening. What we don't understand is time. I mean, when you think of the Bronx, what does the Bronx look like 200 years ago? Right. 300 years ago? My gosh, you're talking about farmlands, you're talking about Indians, a population that's inconsequential. And you look at it today, and you're talking about millions of people. Throughout the city, you're talking about many millions of people. Throughout the coastlines, around the world, billions and billions of people. This is all a factor. It's time. We don't understand time.
Well, that's what you say. You don't understand time, and this leads me to my last question that comes from Kui Yang, who's also a Bronx High School student who sent an email into the show. He said, now, how can you accurately predict the long-term effects of climate on our climate?
Well, you can say that we know the greenhouse buildup is going to make it warmer and warmer. We may not actually predict in each part of the globe what the long-term effects will be precisely, but we know that the poles are more sensitive, and that's where the big feedbacks are. So permafrost is melting, we see that already. Antarctica and Greenland are melting, and although we don't know exactly how fast, we're seeing things that we've never seen before. We've seen that the melting in Greenland is lubricating the glaciers, and they're going faster than we thought. We're seeing, as Bob said, that the big Antarctic shelves are breaking up because sea level's rising and hitting them and breaking them. It's that action as well. So we can't accurately predict exactly when, but we know that these changes are coming. And I think we should put a point in for our Native American ancestors here to think about. They thought about future generations. And we have such a short-term perspective that's what we need to think for the future. We have a chance to save it. We have a chance to stop polluting. There are many, many things we can do. It's up to us. It's really a moral question. And that's what I think Al Gore's movie, An Inconvenient Truth.
Well, that's where I was moving to, because I wanted to ask about where does Washington stand on this? We do know that some people are speaking out. There is an environmental committee in the House in Washington, D.C. Dorothy, I know you had to be excited because we know that former Vice President Al Gore was down at Columbia University, and he spoke on the issue of global warming. Are enough people in Washington speaking about this issue, and what can be done to further get the word out?
Well, I think as Gore showed in his movie, it's kind of like the tobacco industry for a long time. People just were in denial. And finally, I think the temperature records are starting to make people believe it, and we have to do something. And I heard on NPR this morning that the whooping cranes have come back from a population of 4 females to 250 cranes flying now, and that's a huge difference. That bird almost went extinct. So you can see what man can do in a positive way. Right here in New York, there are many, many things we can do.
And Bob was just shaking his head in the
I tell you, the question you asked, I would answer it by saying the government is absolutely not doing enough about it. We should have been in the Kyoto conference, even to put our input in. Instead, we banned it. We and Australia, the only 2 countries in the world, really, that aren't part of this program, which is looking at overall global warming. How can you not know that this is, that we disregard scientists, we re-edit what they say. So I have to fault, I hate to say it, this administration and Congress for not looking at this long term. Do we only care about our lives? Are we worried about our grandchildren, our great-grandchildren, those that follow? It's kind of selfish, isn't it?
Yeah, it is. Well, we're going to wrap things up, but before we wrap things up, now, we can't depend on Washington, and, we can't. We can depend on ourselves. So there's some things that we can do. Talk to some people about what we can do in the short term to really make this situation, can't go away, but make it a whole lot better.
Well, I think we can follow Bob's example in getting a hybrid car. There are many ways we can save in energy. Ourselves. The biggest thing I think we can all do is speak out about it, talk to our neighbors about it, and have a grassroots cry for money going into alternative energy and into saving energy and being a part of this movement to stop what we've already been doing. I think that's the biggest thing.
We're going to have to do it anyway, because no matter how much better we're doing at getting oil compared to what we used to be able to do, it's going to run out at some point, because it's not being reproduced. You can't have forests put under great pressure and create oil over in hundreds of millions of years, and then all of a sudden do it in a few years. So when that goes, the biggest source of our energy from the standpoint of transportation, for instance, is gone. In fact, a lot of air people involved with flying, I'm a pilot, but I got to tell you, it's $5 a gallon now, and it's going up. But that's not the problem. The problem is you can drive a car with a lot of different ways of doing it. You can't fly planes with much of the equipment that we might be able to use in cars. So we're looking at oil also for chemistry. A lot of stuff is made from oil, and we're burning it, and we're polluting.
Well, Bob, we want to thank you for joining us. Dorothy,
Thank you,
it has been
Daren.
so informative, and really, you brought it to light, and now it's up to us to make the difference. But thank you so much for sharing with us.
Thank you.
Dorothy
Thank
Peteet
you.
from Columbia University, Bob Hemm from the Explorers Club, and we're talking about global warming. And if you want to know why it's warm outside, well, you just hear what we just talked about, and you'll know exactly what this is really all about. Well, we got to move some things along, and we want to move from exploring the environment to exploring film. We're going to tell you about an educational film festival. All that and much more is coming up when Open returns.